Anscombe's Quartet. Anscombe's Quartet was developed by statistician Francis Anscombe. The next question is why Anscombe's Quartet? Because it shows us the importance of data visualizations. Anscombe's Quartet comprises 4 datasets, each containing 11 XY pairs. The 4 datasets appears to be similar and using typical summary statistics. Now let's see what Anscombe's Quartet dataset looks like. So this is how Anscombe's Quartet dataset looks like. Dataset 1 consists of X and Y pairs. Then dataset 2 consists of similar X and Y pairs. Similarly for dataset 3 and 4. And each of the dataset consists 11 XY pairs. And seemingly there is no much difference between each of these datasets. The datasets looks almost similar and there is no much difference between the datasets while we examine simply through the dataset. Now let's look at the summary statistics of the following datasets. So we obtained summary statistics for the following datasets. We obtained sum, average, standard deviation and correlation coefficient for each of the following datasets. And we can see that for dataset 1, 2, 3 and 4, the mean of X values equals 9 and the mean of Y values equals 7.5. And the sum for each of the datasets corresponding to X and Y values are also same. That is, for X values, each of the datasets sum is equal to 99 and for Y value it's equal to 82. And now when we look at the standard deviation of the datasets, the standard deviation of X is 3.32 and standard deviation for Y is 2.03 for every dataset. And now we look at the correlation coefficient between X and Y of each of the dataset. And the correlation coefficient is 0.816 and it shows us how strong a relationship is between the two variables. And now when we try to interpret the following data with the help of these summary statistics, we will interpret that there is no difference between the following datasets, or the dataset is representing almost similar characteristics. Now let's try to visualize the Quartet dataset. For visualizing the Quartet dataset, we will use Python. I'm using Jupyter Notebook for executing the Python codes. First code snippet, what we are doing is we are importing the NumPy and Matplotlib packages. And why NumPy package is because it's a core library for scientific computing, and why Matplotlib is because it's a library for creating statistics, animated and interactive visualizations in Python. So we'll execute the first line. Now what we are doing is now we are creating one-dimensional array for all XY pair quadrants. So corresponding to each X and Y, we are creating one-dimensional array consisting of that 11 XY pairs. So now we have created the one-dimensional array also. Now what we are doing is we will be plotting each of the following datasets from dataset 1 to dataset 4. So we will use the following code snippet to plot each of the datasets. For corresponding to dataset 1, we are going to plot it now. We will be executing the code snippet. So this is how we obtained for dataset 1. Now we will do the same for dataset 2. Now we'll try to plot the third one. And the third one is also very different from the dataset 1 and 2 when we are visualizing it. Now we'll plot the fourth one. And when we visualize the fourth dataset, it is very much different from the above three. So What do we see from all these four datasets? This is what we obtained from all the four datasets. All the dataset shows the same regression line. See, every dataset shows the same regression line. The straight line in each of the datasets shows the regression line. But each of the dataset is telling a different story, which means when visualizing, each of the dataset is telling us something different. It is not interpreting the same thing, or it does not show the same relationship between x and y. Now when we look at dataset 1, it consists of a set of points that appears to follow a rough linear relationship. The dataset 1 shows a very rough linear relationship. Then dataset 2 fits a near curve but does not follow a linear relationship. Dataset 2 follows a linear curve, but it does not follow a very good linear relationship. Now when we come to dataset 3, look like a good linear relationship between x and y, except for one large outlier. For dataset 3, there lies a very large outlier, except that outlier, almost all other data points lies within or very near to the regression line. And when we come to dataset 4, looks like x remains constant, x does not change, and for only one xy pair x changes. For all other points x remains the same. So now when we visualize the dataset, we see a drastic difference between the result or the interpretation that we can form from the summary statistics. This is how data visualization helps us to come up with obscure or hidden informations within the data. Thank you.